Hello everyone, I'm Dominik, I work at Talk, I am also the committee for Apache Aries, and today I would like to talk with you about object-oriented programming. I think that we very often on our project we forget about those basic things because we have the mindset of Java beans that have been mentioned on the previous presentation about functional programming, and this is not the truth that it's connected with the object-oriented programming, and I think I will show you that this is another approach that we don't follow in our project very often because we have such a lot of structures, a lot of Java beans, and this is not the world that we are fighting for. Okay, let's start with the quick definition. What is object-oriented programming? If you look at some Java tutorials, or for example on Oracle website, you can find out that in surrounding world we can find out a lot of real-world objects. And if you look at them, you can find out that they share two characteristics. They have some kind of state and also the behaviors assigned to them in some way. So in our world, in programming work, we can create such objects which tries to mimic the same behaviors and functions and look the same as real-world objects. So we are modeling some classes where they have some state kept in fields and also some behaviors hidden in methods. So our programs are a set of simple objects. We should find that those objects should be as simple as possible. And it's nice to think about those objects as small computers. And of course, they have to interact with each other in some way. And the communication is through calling the method of another object or itself. And such methods, it's nice to think about them, that it's a kind of passing a message between those objects. Isn't that simple? Probably it is. The overall idea is pretty simple. But we also have some principles which are really helpful to design and organize classes in our systems. And it doesn't work only on the level of classes. It also works on the level of designing modules, microservices, even big systems, and especially model the things inside and the communication between the things that we have in our systems. So, in terms of those principles, we have 4 basic principles, and you have seen on that, them on the slides. And there will be those principles will be the guides for us for today's presentation. We also have solid principles, and the solid acronym is created from the first letters from the principles on that set. We also have grasp, and this is more the umbrella name for several other principles that you can spot here, and I will mention each of them also during this presentation. You have a lot of another principles. I will try to mention all of them that I remember, but they are not gathered in any set. Okay, let's start with the first principle for object-oriented programming, encapsulation. And when you read a tutorial about encapsulation, probably you know that this is mostly focused about information hiding. But there is also a second factor of this principle, and it could be called grouping data together. And the whole idea, what's going on in encapsulation, can be hidden in one simple sentence: build a capsule. When we create such capsule and we have something which is inside and outside of our capsule, we are heavily reducing the complexity of our objects. Additionally, we have security because we are protecting everything that we have inside from everything that is outside. And in opposite way, everything what is outside, it's also protected from the things inside. So let's create our first object. We'll be, during this presentation, in the domain of task management. And we have created simple class task with one field called name. And if you know about encapsulation, probably something is wrong for you with that class. And you know that you should put the private keyword in front of this field. But very often, a lot of tutorials says, okay, now someone has to interact with that field in our object. So let's expose setter and getter, of course, yeah, especially with public. And we can even generate them using some Lombok annotations, or for one field, or maybe for all the fields that we have inside our classes. And for me, personally, this looks like putting a public keyword in front of the field name. And this is the technical debt that we still have to pay for using and creating Java beans a long time ago. Java beans are not real objects. There are more structures. And I don't want to say that structures are bad. Structures are pretty useful, especially when we want to treat them as data transfer object. And this is really big problem that everything in Java is called objects, and that's why we are not able to distinguish what is really structure, what is object. And this is the pain, yeah? This is why we have Java beans, and we still try to call them object, even if they are not objects. Okay, but what's wrong with such structures? If you have some setters, then you have to ask yourself a question. If you discuss what your object is doing, do you express it in words that you have to set X, Y, Z on your object? No, you should be more focused what is the real behavior assigned to that object, as it's stated in the principles, in the definition of object-oriented programming. So that's why, instead of using each setter in your code, you should use more proper operation name, which is assigned to the real behavior connected with that object. What's more, you have getters. What's wrong with the getters? If the getters return some immutable value, probably everything is fine. Here we return some task name, which is the wrapper from string. Everything is fine. In records, in modern version of Java, you can omit the get prefix at the beginning of the method name is omitted. Everything is fine, but still this is a kind of accessor for immutable thing. But the bigger problem is when you want to return something bigger. For example, collection of some elements. The problem here is that we are exposing outside something that should be hidden. So when you return some list, some collection, some set, you should always wrap it in some immutable collection to don't allow anyone to change the order of elements in that list, maybe add something, remove something, and so on. And even if you protected such collection, you have to also protect all the elements that you have on that list. And you can do this, for example, returning a copy of each element that you have on your list. How often do you do so in your project? Another problem, when you want to return a value that could be available or not. In the getter, you are not able to spot that assignee ID could be null. And in Java, starting from Java 8, we have something which is called optional. And we can return optional from our getter. And yeah, this is not the getter that you can generate normally in your project. And here, I've wrapped in optional one field that I have internally in my object. But you can ask yourself a question, why don't have the optional fields in our code? And there will be, of course, a lot of mess that you shouldn't do so. You will have the warning in your favorite IDE because optional isn't designed for being the field. But you have to ask yourself a question, why people say so. And if you read carefully what is the whole mess about, you can find out that you shouldn't pay attention if you are creating really good, really encapsulated object, because this is something that is hidden inside your object. So if you think, if it's helpful for you, if you want to express that internally in your code something is optional inside that object, why don't mark it in the field type? Okay, another problem with such structures. Let's rename a field in our code. If you use your favorite IDE, click the rename field button or whatever it is in this IDE, you probably will be asked also about renaming the getters and setters. Next step, maybe you should also rename some names derived from getter or setter, or the parameters passed to the setter. And after such changes, when you have such structures, you can then, with a lot of changes, with several files amongst your project. But on the other hand, if everything is hidden when it's encapsulated properly, the change of one field name, for example, will affect only this class, maybe the factory class, maybe the test class, but it should be all. It's hidden inside of our object. Okay, so when we are designing our classes, our objects, we should be more focused on the behavior, because this is something which is exposed outside. So we have created the task class, which have one getter, and we have created this getter on purpose. It returns the immutable value. We also have the methods connected with the real action that you can make with this object. Assigned to, resolve, reopen. It's connected in the you can hear that this is the things that you can really do in normal world with the task element. Okay, here it is also crucial to mention the terms of visibility. Of course, on the level of fields, probably you know that everything should be private. Maybe in some situations, a field could be protected if you want to support inheritance. On the level of methods, most of the methods should be private. Why? Because we are trying to follow the clean code from Uncle Bob. So we are creating a lot of small methods, and they should be private inside our code. Next, we have the package private, which is the default visibility level for everything in Java. And I think this is a good idea to take advantage of this default thing and don't put additional public or protected keyword in front of the class. Even if your favorite IDE generates such code, remove it because it's really nice to have such default level and only expose the thing when you really need. So that's why you have to add the protected or public keyword when you want to expose something outside of your module. The same works on the level of classes. Most of the classes should be private. Most of the internal classes should be private because they should be available only in that class. When you really need to expose them in some way, you can make them package private. This is the default version. And only if you really need to read something from outside of your module, make it public. And I think personally this is a really big problem when people use annotation like visible for testing, because this is the sign that probably the classes are not defined in a proper way and something is broken inside the abstraction that we are trying to create in our code. Okay, so it leads us to the second principle of object-oriented programming, abstraction. The whole idea of abstraction is that implementation in our software is something that changes very, very often. But some abstraction, some higher level picture of the things that we are designing is something that stays with us for much, much longer time. And the whole idea of abstraction is to hide or remove even all the unnecessary details from our code. And when we are hiding those things, we should expose only essential information for all the elements that have to interact with our objects. And we do so. We are heavily reducing complexity, again, as in encapsulation, and also we are improving credibility of our object. And because of that, we are able to be more focused on the problem that we are trying to solve in our code. Okay, so how we should create such objects to keep everything private but expose only the crucial information? The first thing that you have to follow in your code is to create your object as information expert. Information expert principle from Grasp is about delegating responsibility. You should delegate the responsibility to the object who has all or most of the knowledge that is necessary for performing some task. So let's imagine that we have some kind of structure, and from that structure we get the status, also someone who is assigned to the task, and based on those two things, those two fields, we can have some condition and maybe perform some action. And if you look at the code here, you see that probably all the information that you are using here are inside your structure. So why don't ask this structure, can this task be reopened? And if so, we can perform our action. This code looks a little bit better, but maybe you see that when you have to call the reopen method, to be safe, the reopen method should also check internally if this task can be reopened. So we have the rule called tell don't ask, which says that we should call just pass the message to the object, for example, reopen with some specific reason. And as a result, we will return maybe nothing because no news is good news, maybe value true, maybe some new version of this class, of this object when we model our code in immutable way, or maybe we should receive false, maybe some exception when something went wrong. But to do so, we have to model our object to keep them always in a valid state internally. So our validation that we are performing in some classes, in some object, should be as quick as possible. Personally, I think that this is really big anti-pattern. When you do something on some class, we have created that, we call some methods, and at the end, or in the middle of some execution, we ask this class, are you still okay? This is something bad, because when someone forgets about that, it could cause very, very big problems. So, personally, I think that we should validate as soon as possible all the incoming parameters, but also all the things that we set at the end, that we set up inside our object at the end of execution of all the methods. Okay, so we are creating such information experts, and the next step is that we have to know that if we have a lot of such information experts, we have to respect that they are also information experts. And that's why we have law of the matter. The whole principle of law of the matter is about not talking to the strangers. Let's imagine that in our specific subdomain, we have to, in our task, we have the logged work property. And we want to log some work in that class internally. So what we can do, we can get work items, and to the thing that we received, we don't know, maybe it's list, maybe it's another object, and we shouldn't know, because this is not our friend, this is stranger for us. And here we add new work item, but we don't know what is this. So instead of having code like that, we should delegate the responsibility to this object internally, I mean to the logged work, and call a specific method, and only here internally we should do the operation that you have seen on the previous slide, but this will be the internal thing on our new information expert. Okay, here it's also crucial to, I think that it's worth mentioning, to think about creators in our code. In terms of graphs, we very often think about them that they are some kinds of factories. And when we think about factories, we think about the object which creates some object, for example, a specific subtype for some parameters, for some complex parameters. But I think that we should also think about local factories. So our log work method from some incoming parameters can create some work items and store them internally. And for us, this is some kind of local factory, and we are responsible inside such code for such one property, and we should keep it as private as possible because we are responsible for the things that we have termed. Okay, when we have created so many information experts, they are respecting that we have such information expert, but sometimes you don't know where to put specific behavior. And for that, you have the principle called pure fabrication. Pure fabrication in a domain-driven design, it's really connected with the domain services. But for us, it should be connected also with a lot of utils that we are creating and putting them also in some commons packages. Let's think about example of such domain service or some such pure fabrication. We have created task estimation calculator, which the only behavior is to calculate some final estimation from some list of tasks and also add some amplification because, for example, we know that our teams is too optimistic in estimations. But this is hidden inside that class, and this is only duty of that class. And it leads us to another principle that we have in Solid, which is called single responsibility principle. This principle is about creating classes or methods that should have only one reason to change. It's not about doing one thing. It's about managing one thing and doing it in a proper way. So our objects that we are creating should follow the high cohesion principle. Cohesion is a way of measuring how much elements inside some module, whatever it is, belong together, how much they have to be used in common, how much they have in common in our code. And of course, you can take advantage of the IDE or some static analyzer hints in your code, but it's nice to know what is the metric that allows you to measure if your class is properly shaped. So here you have the lack of cohesion of methods. This is it's abbreviated to LCOM4 because this is the fourth version of this metric, and it tells you how many clusters of methods and fields you have inside your code. If the LCOM4 is equal to 0, you don't have any method in the class. And probably it's fine when you are creating a structure. LCOM4 equal to 1 means it's perfect situation, yeah? All the methods and all the fields have to be used in some way together to express the behavior inside your class. If the LCOM4 is bigger than 1, this is the hint for you that probably your class should be divided in several other classes. And of course, the number of classes could be described as the result of the metric, but still, you have to design it. Maybe it's your decision to, for example, create some kind of facade, and then you are not following this metric, but this is your decision. Okay, and it's worth mentioning that methods like equals, hashcode, toString, all args constructors, and such alike, they very often use all the fields and they build one big cluster. So such methods should be excluded from this metric because it makes it always equal to 1. Okay, so we are creating such classes with high cohesion. But when in terms of communication between classes, we want something opposite, which is low coupling. And coupling is a way of measuring how much in relation we are with another classes. So for example, we know about another class, another element, another object. Maybe we use that object. Maybe it rely on some specific order of execution of methods, maybe on some internal state. And we want to keep such connection as small as possible. If we do so, we are minimizing dependencies in our software, in our code, as much as possible. And also, the changes that we apply in our code could be more local, more focused on the one thing that is represented by your objects. And also, such components could be easier to reuse because you don't have to take the banana with the gorilla and jungle and several other things. And here we also have nice technique to check what is how it works in your code. So here you have the CRC cards, and this is very old technique. The CRC stands for Cross Responsibility Collaborator or collaboration, depending on the information that you have or the version of these cards. And here you have on a small piece of paper, so you can use this technique without even writing a line of code. You name something. You add all the responsibilities of that class and also all the collaborators which are necessary for performing such tasks. So they are not fields, they are some other object that we have to call, for example. And if the one or the second list grows too big, it's the sign for you that probably something is wrong in the design of this class, of this object. So here we have to, in some way, untangle your class. And here we have nice technique which is helpful in such moment. And this is called dependency inversion. Dependency inversion principle from Solid is about creating high-level components which are independent from low-level components. Or, in other words, we should depend on abstraction, not on concrete objects in our software. So let's imagine that we have some kind of task service somewhere in our module. For us, it will be the controller in terms of grasp. I know controller is a buzzword in our world. So we can also call it dispatcher, next buzzword. And if you have so many controllers, so many dispatchers, we have to distinguish and say that controller in terms of grasp is not the same as controller in terms of MVC. Controller in terms of grasp works on the level of traffic inside your module, and controller from MVC works on the level on connection between HTTP and your code. Okay, so we have created such task service, and you probably want to hide it in some way because this is some specific thing, how you traffic your code inside your module, inside between your classes and so on. And you want to create some higher level component. And that's why you have indirection. Indirection is about, in Java, it could be mostly created using the interfaces, but also, mostly with interfaces, of course, you can take advantage of the design patterns like adapter, facade, mediator, bridge, and so on and so forth. Okay, so for our task service, we want to create such higher level component. So we can create task other, and it will be one interface, one higher level component, which describes specific, for example, use case of our module that we have. Of course, to add a task, you will have to know about some message queue. In our case, it will be the RabbitMQ. You also have to save something in the database, and we will do it using the JPA task repository. And as you can see here, you have a lot of low-level components here, and you don't want to have the connection between them because they are responsible for different things. So we should probably add some indirection again using the interfaces. So we have created event sender and task repository, and it makes our code decoupled because, as you can see on the screen, every lower level components depends only on the higher level components. Okay, we have to be called in some way. So we have real MVC controller, which is called task controller. But this is not the only way how we can add a task to our system. We also have the event handler. And we can create some tasks from some events. And here, you can create a boundary around the interfaces, around such higher level components to create your module. And this is the example of hexagonal architecture. This is the basic idea of hexagonal architecture, which is really useful for creating business applications, where in the middle of your application, you have domain model and application services working on such domain model. You have boundary of ports and also the adapters, which allows you to interact with some external things like HTTP, maybe databases, maybe message queues, and so on and so forth. Okay, when you are creating such higher level components, when you're creating such interaction, you have to pay attention to don't have leaky abstractions. Example of such leaky abstraction you can find out even in Java. At the end of the stream, you can call the collect method and pass a specific collector, for example, to list. And the return type is interface list. And if you try to add something to that list, everything will be fine. But starting from Java 9, as far as I remember, you have toList method. And if you call that method and try then add something to such list, you will receive the exception. And the problem is that we have received the immutable collection. And the bigger problem is that list in Java 17 or 18 now has more than 20 methods. Some of them, like contains, size, stream, are pretty useful in several contexts, and normally you can assign such behavior to all kinds of lists. But there are also methods like add, remove, set, clear, and those method names even imply that your object is mutable. And this is something that is unexpected when you create immutable structures and still use the same kind of interfaces. And this breaks the next principle that you have in Solid, which is called interface segregation principle. This principle is about creating small and concrete interfaces, and it's better to have several interfaces with 1, 2, maybe 3 methods, which express our abstraction that we have created in a proper way, than having one big interface with, I don't know, 20, 30 methods, because there will be always someone who will implement them in a not expected way. Okay, specific way of abstraction that we additionally have in object-oriented programming, it's inheritance. And this is also the third principle of object-oriented programming, the third big principle. The whole idea of inheritance is to create new classes based on existing another classes. So, for example, we can still have our task class, but for some specific reason, because, for example, we need some additional data internally, maybe we want to tweak a little bit some methods, maybe add some methods, we want to create programming task, also research task, and several other more specific types of the class task. And here we can create the instances of the task class and all of the more specific types. Sometimes you want to prohibit that, so you are using the abstract. You want to mark that this is only the abstraction. Okay, no matter what you choose, it's important to follow Liskov substitution principle. It could be described into simple rules. Don't surprise me and respect the contract. Because the whole principle has some mathematical formula how you should design your classes and the relation between the specific classes and base class. But the most important is to remember that all the specific classes have to be able to be used in the places where the base class can be used. And of course, it also works in terms of interfaces, but here we will focus on the classes. As an example, let's imagine that we have the estimate method in our class task, and it returns the estimation. Of course, it's abstract, so we have to implement it in another place, but we have some kind of contract. So in our calculator that you have seen before, probably you can, on a list of tasks, create the stream of them, and then get the estimation, and then make some reductions, multiplication, and so on and so forth. And this code works fine if everyone follows all the contract that we have stated. And when someone throws, for example, the exception inside the estimate method in the more specific class, it's something that is not expected. And this is not only this more specific class to be blamed for that, because the task class is also responsible for this problem, how we designed it, of course. So when we are designing our base classes and all the abstraction that we have, it should be done in such way that our code should be open, that should be follow open-close principle. This principle is about creating classes, methods, or module in such way that they are open for extension, but in very specific way. For extension, which are closed for modification. So you can extend the code in some way, but you shouldn't modify the source code of this code every time when you want to, for example, create more specific classes. And to do so, you have to follow principle from Grasp, which is called protected variations. This principle is about identifying possible changes in your code and all the instabilities, all the difference, what can be wrong, what can go wrong with your interface. And around that, you have to build stable interfaces and describe them in a proper way. So now, after the lesson with the external task, it would be much better to return the optional of estimation, of course starting from Java 8, to tell explicitly optional is the way of describing that estimation is available or not. Don't throw exception. You can do it in another way, but this is the obvious way how you can do this using your types, using the signature of your method. Okay, when you are creating, when you are creating the classes in such way, you are avoiding leaky abstractions. And leaky abstractions in terms of inheritance, it's when, for example, you have to check what is the specific type of the class that you have received. And for example, when it's external task, we'll have to wrap the estimate method in the try-catch block, and for all the other task instances, whatever the type we have here, we can run normally the estimate method without any problems. And this is the problem that I often see now with sealed classes. And this is really fancy feature that you have in modern version of Java, where on the model or at the moment of compilation, you already know all the possible implementations of this class. So for example, here we have a status class, which is sealed, and it has only two options. It can be success or failure. And in modern version of Java, or the version that will come maybe in half a year, we can write some switch statements using even the pattern matchings. And here, for example, we can distinguish. If it's a success, we can do one action. If it's a failure, we can do something different. And the problem with that code is when it's hidden internally in the sealed class or sealed interfaces, because we have also sealed interfaces, everything is fine. But when you have in several places around your system such switch statements, at the first sight, it looks fine until someone adds something new to that code. And this is the problem that in small environments works very well. And recently I read an article about data-oriented programming in Java, where you take advantage of the immutability, especially the records that you have in modern version of Java, sealed classes, and also the pattern matching that you have from sealed classes. And I think that here, when you have really stable data and small code base, it's fine to go with that approach. But for a bigger problems, when you write them in an object-oriented way, this is something that should be that could harm your project on several ways. Yeah. Okay. So here, our abstraction, our leaky abstraction, have also another side. We can also create unnecessary abstraction. And this is also a very big problem. We shouldn't create stuff that is unnecessary. The example of such unnecessary abstraction, you can find out even in the class, which is the root of all the classes that you have in Java. You have object class, which has a method toString equals hashcode. And every Java developer knows that before using these methods, in your code, probably you have to override them in the classes that you have, because normal implementation, the built-in implementation, is just wrong. It's just useful for most of the software that we are creating. I would prefer more the Haskell approach, where you have type classes. Of course, we don't have type classes in Java, so we have the interfaces, which describe that my object supports to printing, and it has toString methods, or supports equality, and even here with the generic, to express that my object can be comparable with another objects, and in all the other cases, you shouldn't do so, because this is probably a problem, some mistake inside your code. Okay, so if we have so many problems with inheritance, maybe it's a good idea to prevent inheritance in our software. And remember that allowance for the inheritance, it's your design decision inside your code. And you should decide always what and how can be specialized in your code. And it doesn't break the open-close principle. Let's imagine that we have a final class And it's okay, yeah? We are not designing this class internally to be able for being extended by another classes. Even if we design such class for extension, then all the methods that we don't expect to be extended in some way, mark them final. Don't allow anyone to change them because it could break your code, or you have to think about that. I like the Kotlin approach where everything by default is final. Of course, you can use some plugin to open everything, but normally everything is final, and you have to explicitly tell the compiler that this class is open for extension, of course, of inheritance, and also the method here also you can extend. But all other classes are final by default, and I think it's great in Kotlin. Okay, and I often ask myself a question, why we still use inheritance so much, so often in our code base? And I think it's because we know the rule called don't repeat yourself. And we very often think that this rule is about don't repeating field groups. Maybe it's not about repeating behaviors, but it's something deeper, because the whole idea is about not repeating business concept. If you have two similar things, you have to ask yourself a question. What will be the evolution of these two things? And only if you really know that this is the same concept, this is the same thing, you can create one piece of knowledge and one representation inside your system which express this thing. In all the other cases, probably you should leave it alone and check how it's gonna evolve. Okay, so the question for you is always, should I use the inheritance in my code? And I like the quote from children who very often say, this is the same, but different. For us, it means illogical, and we very often in such way creates our hierarchy of classes. I think we should put on some kind of scale how our classes that we are creating and check how much they are close to the same from all the perspectives and how much they are different from each other. And only when you're really close to the same, especially with the base class, you should follow the inheritance. In all the other cases, probably inheritance is not a good call. So, remember additionally that inheritance is a specific form of coupling, and especially in Java, where you have a single inheritance and you cannot extend a lot of classes. It's really tight coupling your base class with all the specific classes that you have created from that class. So maybe it's a good idea to try something different. And this different thing is a composition. Composition is using another object to express your behavior, in simple words. So we can combine them in some way, or we can take one object, decorate them, and only delegate the actions in some specific situations. So, for example, for us, it's good enough to create the interface here. For example, estimable. Maybe the name isn't so good, but it will be good enough for our example. And we can create a class, and such class can be marked final, but we still implement some interface. And because of that, we can create our own class outside of hierarchy of classes of the task. For example, external duty, which implements some specific interface, the interface that we have created before. And here internally, we can have a task property and delegate the behavior to that task only when you really need to do so. But it will be hidden inside of our object. That's why I think the good interface is very often good enough in our software, and people want us very often to prefer composition over inheritance, and it's very, very good decision because it makes our code much more flexible than one strict hierarchy of classes that we are very often creating. Okay, with inheritance, people very often connect the fourth principle of object-oriented programming, which is polymorphism. But it's not connected so tight. Polymorphism is also the pattern that you have in Grasp. And from Greek, it means many forms. And you can ask yourself a question, what can have many forms? And it's, of course, about one method name that could bring us different functionalities in our software. So how you can distinguish between those functionalities if they are named in the same way? And this is because you have your type system in your object-oriented programming. And the first manifestation of polymorphism is, of course, overriding, and it's very often connected with inheritance. And in overriding, you can create some object some method in a base class. Of course, it's not final. So in the more specific class, you can override that method, and in runtime, when you have only the task class, the runtime will make the decision which object estimate method should I call, and it will depend what type internally of the task you will have. But in our situation, it's only important that we receive the task, and that's all. Okay, the second manifestation of polymorphism is overloading. And overloading is when for one method name or constructor, because this is a specific method only, you can pass some another task as a sample, of course. You can pass only the name and labels, and so on and so forth. And this is the great way to simplify our API in our software. Additionally, we can still use the same names that means something for clients of our API. And this is the place where we very often add some default values to our software. Because we are doing so, this is also the great way for evolving our API. So we created our object very, very long time ago, and it has the finish method, and it is coupled to the constructor of some moment of time when the task was finished. And this code is really hard to test, really hard to pass the different value, because it was designed to work in such way. And the next step is that we want to be decoupled from this static factory of instant. So we can create new method finish, and we can as here we have new parameter instant when, and previous method could use the default value that it has previously. And now probably the finish method without any parameters is something that we keep in our code, but only for a moment. But in long shot, we want to remove it. So let's mark it deprecated. Your IDE will help you to find all those methods. Your clients will also know about that, because this information is also seen in the distributed jars. And in the future versions, of course, you have to probably break the major point of version in your code if you follow semantic versioning, and probably you should. You will have to bump the major version, and then you will be able to remove that method at all from your code. But remember that overloading is not a silver bullet in your code. When you have a better name, which expresses in better words what's going on inside that method, use the better name. Don't stick with the old one. Okay, that's all of the principles that I have prepared for you today. And now I want to leave you with some key takeaways. First, hide all the unnecessary details or remove them. Maybe they are not necessary. We want to only have some higher abstraction which only solve for us some specific problem that we have in our code. Because of that, we should expose only necessary information outside of our object. We should create such information experts. We should know the rules, know the principles that are assigned with object-oriented programming, and don't say, I don't use object-oriented programming because I don't want to create Java beans. This is not object-oriented programming. And the thing which comes from that is that all those rules are not enforced by the compiler. You can, of course, take some plugin which, for example, checks all the metrics and say that probably something is wrong in your code. But this is your decision to add such plugin. You should know when and why you can break those rules in your code. For example, make some technical debt. But this is your decision that in that place it will be helpful. Maybe in future I will clean it up. But I know what I'm doing in my code. And that's why I think we should always design our classes. Don't just write them, don't just use them as they are generated by your favorite IDE. When it's public, I leave it public. No, keep it as private, as encapsulated as it possible, and this is real object-oriented programming, not the Java beans. Okay, thank you very much. This is all from me, and if you have any question, this is the perfect moment.
Hello, thank you for your presentation. In your opinion, should the principle that a class should be small and have one method prevail over the real business meaning of the class? I don't know, for example, should cinema be splitted into screen, audience, and entrance? Please note that in that scenario, there is no cinema left.
I think, of course, it depends, yeah, but we should be focused on the one responsibility, yeah, and this that the class has only one method, and this is the only one responsibility. Probably it's fine, yeah, but when you have several classes which looks the same, uses the same things internally, and have nearly the same methods which corresponds only with that one element, probably it will be a pain in your code, in your design, yeah, because we have to create all of them. It's helpful to use, of course, dependency injection framework to do so, and everything looks fine at the first sight. But then you probably will have to, in some way, share the state internally, and I think it's something that should be avoided. But of course, you have to look at your object always and think what is the real responsibility of this object, what are the real responsibilities of all the other objects, and when they are really close enough, maybe you want to have them, the overall responsibility could be merged in one class because it will be cleaner from the point of design. As I mentioned, yeah, it's not about doing one thing, it's about having one responsibility, and you have to ask yourself the question, what you can call the responsibility in your code, yeah?
I remember there was an example on in your presentation. I think this was tell not ask, something like object reopen.
Yeah.
And maybe you said it, but I didn't. Maybe I didn't catch it. How do you represent the situation of failure? Should it return some kind of I don't know, true false, some kind of object, or maybe throw an exception, or what would be the answer?
Here, yeah. Of course, if the duty of your class is to perform that action, yeah, then you can respond with true, false. Of course, this is one of way of expressing that. But you can also throw the exception, yeah. If you want to follow some functional and use some functional structures, of course you can return either or some other types which additional will have the information even if type that what kind of exceptions you can have and what is the proper value that is returned. Yeah, you can of course return nothing. Yeah, when everything is fine, and you can return the new version of the class if everything is immutable. Okay, so it depends what are the conventions inside your project, how you design your classes, and maybe it also comes from the overall design of the software that you are creating. Yeah. Okay. If there are no other questions, thank you very much.